everyone, welcome back. This is a Calculus 3. So in this video, we're going to talk about 2.2 vectors in three-dimensional space. So in chapter 2, if you watched the video in the last time, we introduced the concept of vector. And then in this video, we are going to talk about the same thing, vector, but specifically in three-dimensional space, okay? So we're going to focus on how to describe three-dimensional space mathematically. And we're also going to locate the points, the vectors in three-dimensional space. And we're also going to think about some applicational problem in terms of vectors. All right, so let me introduce the vector in three-dimensional space and how it looks different from two-dimensional space. So vector, if you remember, it's a very unique. It's the same like a number. It's a quantity. It includes magnitude and direction. So if you remember, in two-dimensional space, you have a vector, and then we have a1 came from the x-axis. So this is a1, and a2 it came from the y-axis. So we were able to locate this a vector, and then we know this is initial, terminal. You can measure the magnitude, length, and you can also think about the direction where they're heading to. So in two-dimensional space, we practice how to operate them and how to convert from this regular vector to the component vector system in terms of the radius and theta. And we practice a couple applicational problems. So we are going to expand this knowledge into three-dimensional space. So what does it mean, three-dimensional space? So if you remember a little bit of knowledge, one dimension, second dimension, and three dimension in math, one-dimensional space, we have only line. Okay, so whatever number, you have only one variable x. Okay, so x can be any number. It could be positive or a negative number. So you have only one variable. In two-dimensional space, we have a two variable, x and y. So whatever the number could be existed on the x-axis, and you have another variable on the y-axis. What is a three-dimensional space? We are adding one more axis. So you could have x, y, z, right? So I want to point out what is a 1, 1, right? So 1 came from the x-axis, y came from the y-axis. The second one came from y-axis, and last one it's coming from the z-axis. So you are going to deal with three components, and then we are going to describe the vector in three-dimensional space in 2.2. Okay. So it's a very similar, characteristic from 1 to 3, just we are adding one more variable. So one thing I want to just, see the difference between 2 and 3-dimensional space. You're going to have more combination in space because you have a 3 different variable. So let's take a look at the definition first. In order to represent points in space, right? Always you're going to consider the origin 0, 0. So that's the 0, 0. And then now we are going to deal with 3 variable. So we have an x-axis, y-axis, and z-axis. And then depending on the combination, you could have xy plane, xz plane, and you will have a yz, 3 different plane. We call this as a coordinate plane in three-dimensional space. Okay, so more specifically, look at this image. Okay, so mathematically, how to describe the points in three-dimensional space? It's gonna be same like x, y, 0. X from whatever the first number is from the x-axis, whatever the second number from the y-axis, and then the last number is from the z-axis. So we are going to deal with 3 different number coming from 3 different axes, and all x, y, z should be the real number. It could be positive, it could be negative. So look at this image. Okay, so if you remember, in two-dimensional space, we have a 1, 2, 3, 4 different quadrants. Do you remember? So in the first quadrant, both x and y, they were positive. This is y-axis, this is x-axis. In the second quadrant, x is a negative, y is a positive. And third quadrant, both x and y were negative. And last quadrant, positive and negative. So you observe 4 different combinations to describe, x comma y in 2-dimensional space. But look at them. Look at this. We are dealing with the 3-dimensional space, and you will see more combinations. So I will show you in this image. So we have x, y, z. So if you write down all the 3 possible combination, all x, y, z could be positive, 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 right? Or positive, positive, negative, positive, negative, positive. Or you could have a positive, what else? Negative, negative, and negative, positive, positive, negative, positive, negative, 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 positive. I'm just writing all the combination. And what else? So we have 1, pretty much 1, 2, 3, 4. Yeah, we have only this combination. So what happened? We have a 1, 2, 3, 4, 5, 6, 7, 8. You will have 8 different rooms. So in the 2-dimensional space, we had a 1, 2, 3, 4 different rooms. If you consider as a room, as a quadrant, as a room, you will have like 1, 2, 3, 4, 5, 6, 7, 8. 8 different, possible combination when you're describing x, y, z vector. Okay, we call that as octant. Okay, so I'm trying to give you guys the idea, the basic concept of the 3-dimensional space, and then we're gonna see more characteristic, the vectors in 3-dimensional space. And one thing you can see, the difference between 2D and 3D. Oh, there are more possibility. There are more combination when you're describing x, y, z variable in 3-dimensional space. And let's take a look at the example. Okay, we're gonna see more example, but here I wanna observe a couple of things. So when you see x, y, z axis, I mentioned that you will have 3 different plane. What does it mean? You can combine x, y axis. So you're gonna have x, y plane. So if you have x, y plane, this is your x, right? This is y, this is x, this is y. So when you have x, y plane, you will have this space. This is x, y plane. And then in x, y plane, always a z variable is a 0. Okay, just be aware. Another one, when you have yz, so this is a yz plane, your variable is coming from only x and z axis. There's no variable from the y axis. So this is going to be the second plane. And the last plane is going to be yz, which is this plane. And then there's no variable from the x axis. So you have a 3 plane, right? So you have 3 different plane, x, y, y, z, and y, z. So that's why when you're combining 1, 2, 3 plane, there will be, they're going to create 8 different routes, right? So here 1, 2, 3, 4, and bottom 1, 2, 3, 4. So that's why you have 8 different combination to describe the vectors in 3-dimensional space. Okay, so just be aware. That's the similarity and difference in between 2nd and 2 and 3-dimensional space. And then we're going to talk about more vectors later. So let me go down slowly. So I want to really point out, right? So you want to point out, you want to see visually how to point to 1, negative 3, 3. So we know that 1 is from x-axis, negative 2 from the y-axis, 3 from the z-axis, right? So this is definitely in 3-dimensional space. How do I imagine the location? So it is a really, really difficult because you have x, this is x-axis, y-axis, and z-axis. 1 is from, so you have it here. So I'm gonna write it, I'm gonna bring this one. So if you go to here, this is negative x. If you go to here, this is negative y. If you go here, this is a negative z. So these are positive and then the dot line is a negative axis. So we have a 1 somewhere here, -2, it's somewhere here, and 3 positive here. So they're indicating. So 3, so I'm going to change the color, 3 from the Z, and then Y, right? Something passing through here, and X is passing through here. So somewhere here, they're interacted somewhere. This is going to be the located 1, -2, 3. So I know it's a little bit difficult. So let me go to here. So this is a GeoGebra website that helps you to see the 3-dimensional space more visually. So I actually type 1, -3, 3. So 1 is from the, actually, let me just loading again. So this is the, oopsie. Actually, I want to type 1, -2, 3, right? So I want to locate it. So when you look at, this is 3-dimensional space, you see that? This point is on the air, right? It's really hard to graph it. So that's why, it's it could be an abstract concept, but we're going to talk about a lot of characteristics. So that's going to help us to imagine the vectors in 3-dimensional space. So just be aware, 1 is from the x-axis, okay? -2 is from the y-axis. I believe that is a green line. And then Z, 3 from the blue line, that is a z-axis. So that's your image of the 1, -2, 3, okay? And then let's go back. Let's go back to this here. So usually the GeoGebra website can help us. I can share this one through the discussion board link later. But anyway, we just be aware, okay, 1 is from the x-axis, -2 from the y-axis, 3 from the z-axis, and the intersected point from those 3 different axes, that's where this point is located. Now, I want to talk about it. I want to talk about the xy, xz, and yz plane. So one thing we know, okay, if I just want to draw this point, if I want to point this point, if I want to locate this point on only xy, xz, and yz plane, what does it mean? So here, let me write it. XY plane, right? We just talked about it, covers the variable that are only x in, what do you guys think? X and y axis. It indicates that whatever the z axis, it's going to be 0. So therefore, if you want to locate 1, -2, 3 on xy plane, it is going to be 1, -2, 0, because xy plane covers only x and y axis. So likewise, you can continue the rest of the. I'm going to minimize a little bit. I'm going to copy, paste, and paste here. So what happened? We're going to talk about the next one. Y, xz plane covers only x and z. That means y equal to 0. So therefore, this, points will be 1, 0, 3. Okay, so that's how we are going to project this given point onto xy, xz, and yz plane according to that characteristics. So the last one, it's going to be yz. So we only cover y and z. So the x is a 0. So in this case, you're going to locate it 0, -3 and -2 and 3. Okay. So just I want to emphasize on one more time the coordinate 3 points in 3-dimensional space. We have an xy, xz, and yz, and then they have each characteristic. So when you locate it 1, -3 and 3 based on the coordinate points, you must have 0 somewhere. Okay, so that's the characteristic of 3-dimensional space. One thing. Okay. Okay, I'm gonna keep going. So this is pretty understandable topics. Let me keep going because I'm gonna show you many small concepts in here again. So let's take a look at the next concept, the distance formula. So same thing, if you remember in two-dimensional vector system, you have an initial point and you have a terminal point. So let's say we have a B, let's say we have A. You were able to find out the distance, the length, which means the magnitude. So if you remember the AB vector, that was, let's say if it is x2, y2, and x1, y1, we calculated y2 minus y1, sorry, my bad, x2 minus x1, y2 minus y1. That was the distance between x and y, between 2 points in two-dimensional space. Do you remember that? And then you can find out the magnitude, the length is going to be, right? The x2 minus x1 square plus y2 minus 1 square, you can find out the magnitude. So we're gonna do the similar thing in three-dimensional space. Let's say I have two different vector. One is a P1, another one is a P2. How to find out the distance between? This is the formula. You're gonna find out the each difference, right? X is a difference, Y is a difference, Z is a difference, and square of it, and then put the radical. So that's going to be the distance formula between 2 points of the in the three-dimensional space. Okay, so nothing is special. Very similar topic. We talked about it. So therefore, it's a similar. So let's take a look at the example, how to find out the distance formula one more time. So this is the image. I have 2 points. So you can find out the distance. So that you're going to find out the difference on X, Y, Z, and square, put the radical. So based on that, let's quickly calculate it. I'm not going to spend too long in this question because it's pretty, we're going to follow the formula. So distance, we have 2 points. So the distance will be big radical, X is a difference, square, and then Y is a difference, square, and then Z differences and square. So if you calculate it, 9, because 3 square, and negative 1 plus 4, this is a 4, and 16, 9, again, this is a 50. So you can simplify, this is 25 times 2, which is a 5 radical 2. So this is the distance between 2 points in three-dimensional space, okay? So you can imagine the image here. So in exactly second example, P1 is located here, P2 is located here. I want to find out that distance. So same thing, you can do 2 minus 3 square, 1 minus 1 square, negative 1, negative 5 square. So you should find out radical 41. So this is how you find out the distance between the 2 points, okay, in three-dimensional space. I'm going to keep going the next question. Ooh, here we go. Now I'm giving you 3 points in the space. So you can think about, we have X, Y, Z. Let's say A is here, 2, 1, 0. And then let's say we have a B here, 3, 3, 4. And let's say C is here, 5, 4, 3. Maybe it's not true, but anyway, 3 points gonna create kind of like a triangle shape, correct? They wanna see when you find out the distance distance of each length, they wanna see that whether it is a isosceles triangle, right triangle, or nothing. So let's do this work. We're gonna find out the distance, everything. So let's find out the distance between A and B, okay? So how are we gonna do it? A and B, all the radical, A and B. So 3 minus 2 square, 3 minus 1 square, 4 minus 0 square. So we have 1 plus 4 plus 16, gotcha, 21. So this is the distance between A and B. And then distance between, let's see, A and C. So that would be A and C. So 5 minus 2 square, 4 minus 1 square, 3 minus the 0 squared, boom, boom, boom. We have a 9, 9, and then that would be 27. That's the distance between A and C. Last one, distance between B and C, right? Because we have 3 sides. So B and C will be 5 minus 3 squared, 4 minus 3 squared, and 3 minus 4 squared. So if you calculate it for 1 plus 1, we have a radical 6. So how do I know that this triangle is going to be isosceles, right triangle, or nothing? So we're going to look at the size of those 3 number. If I want to prove that it is a right triangle, it must be satisfied with the Pythagorean theorem. Excuse me. So Pythagorean theorem is whatever you're adding to length is going to be equal to the last length square. So I feel like it's going to work if I do have radical 6 square plus radical 21 square. If I'm adding those two after square of it, what do you guys think? It is going to be equal to 27 radical with the square. Yes, 6 plus 21, exactly, it's valid. So we just proved that. We prove that these 3 points create a right triangle according to, we prove that AB square, the length AB square plus BC length square was equal to AC length square. We just proved that. So in this space, this 3 points gonna create a right triangle if you connect them. Okay, so I'm not using any fancy word. It's pretty understandable topic, although we are dealing with the 3-dimensional space and dealing with the 3 different variable. It's a pretty understandable topic. Now, in the next concept, you will see many interesting geometric shape in 3-dimensional space. Again, if you remember a little bit of background, what do you guys think? The cubic. This can be described in 3-dimensional space, or cylinder. This is also 3-dimensional shape, because if you have a 2-dimensional image of the cubic, it's going to be only the right or rectangular or circle. Or if you have a sphere, this is also 3-dimensional geometric space. So we're going to focus on the sphere shape, because this is going to be in 3-dimensional space, right? So if you remember, circle equation, right? Circle equation, I'm going to just make it smaller. So circle equation in 2-dimensional space, if you have a radius, and let's say you have a x0, y0 as a center, everybody knows how to write the circle equation. So x minus x0 square, y minus y0 center, and then r radical. This is the circle equation in 2-dimensional space. We are dealing with the equation of sphere, right? So what do you guys think? We have one more variable because it's in 3-dimensional space. Sphere is in 3-dimensional space. So therefore, you have center at x0, y0, z0. And then the radius is going to be existed. So the formula is going to be, if the center is x0, y0, z0, with the radius r, the formula is going to be that. You see that? X minus, same thing. And then square, square, square. So that's the sphere equation. Because this is one of the popular shape you will see a lot in 3-dimensional space. So let's take a look at the example, how to find out the equation of sphere with the given points. So the sphere is exists in 3-dimensional space. So we have the formula very similar to the 2-dimensional circle equation. So find the equation of sphere. Oh, they gave you the center and the radius is 3. What is the intersection of the sphere with the each x, y, y, x, z, and y, z? We know all the characteristics. So first of all, center of sphere is a given at 5, 3, 2. Radius is a 3. So therefore, x minus 5 square, y minus square, z minus 2 square equal to r square. That's going to be our, what do you guys think? That is going to be our equation of sphere. Am I correct? So we just found it. So this is going to be equation of sphere. Now, they want to find out the intersected points of each different coordinate plane. So this is a sphere. So looks like this is the image. So we have a 3 different plane, right? So one is here. Another one is something where here. And then another one is in the bottom. So we have a 3 different space. If you remember, go up, 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 up. We have a 3 different space in 3-dimensional space. This is your, right? This is your XY, YZ, and XZ plane. And then each plane has a characteristic. Something is a 0. So we're going to use the characteristic. So let me go down. So let's find out if the equation of sphere intersects with XY plane, right? Then what do you think? Z variable is always a 0, correct? So this is the first scenario. I'm going to copy and paste because we have a 3 scenario. So the second one, third one, and then I'm going to change the number. So one is XY, second one is XZ. So the Y will be 0. And the last one, YZ, X will be 0. So if we have 3 cases, what happens? So that means we have this circle equation. I'm going to copy, paste, right? And what happened? Z equal to 0. So the Z, you're going to plugging in 0. Am I correct? Here, I'm going to make a circle. I'm going to paste everything here. Here. And then what happened? For the second case, Y should be 0. Y should be 0. And then third case, X is going to be 0. That's where you're intersect with each different coordinate plane, correct? And we're going to just calculate it, the rest of work. So this one will be X minus 5 second, Y minus 3 second. If it is a 0, we have a 4 equal to 9. So therefore, X minus 5 second, Y minus 3 second. I'm going to subtract 4 to other side, 5. So what does it mean? When you interact, when this equation of sphere equation interact with XY plane, you will find out the circle equation. This is a circle with center 5, 3 and radius is radical 5. So that's what your answer. Because when you are intersect XY plane, right? When you intersect with the XY plane, one of the variable is going to be 0. And that moment they're hitting the XY plane. So let me just look at the image, right? So this is XY plane. You can think about it. This is XY plane. I'm going to write it more. So this is XY plane. And I do have a sphere. What do you think? This is intersected image. This is intersected image, which is your circle equation, correct? So same thing is happening when you are intersect, when the equation sphere intersect with other plane, the intersect image is going to be circle. No matter where you are here, you're going to hit the circle. If you're, bottom, they're going to hit the circle. So we're going to find out all that equation. Does it make sense to you? So we're going to go that second case, just simple calculation. So now that is a 0. So X minus 5 square 9, because that's a 0. And then we're going to get plus Z minus 2 second equal to 9. And then I'm going to move this one to the other side. x minus 5 second, z minus 2 second equal to 0. So this is also circle equation with center at 5,2 and radius is a 0. So it's it's like a dot, right? It's like just a point. So when you hit the xz plane, they're not going to be even like a circle. It's just a dot, right? Because the radius is a 0. It's like a dot at 5,2. This is a circle shape. Okay, let's check the last one. So the x is a 0 when you hit the yz plane. So it's a 25 plus y minus 3 second, z minus 2 second equal to 9. So y minus 3 second, z minus 2 second, it's going to be moved to the other side, negative 16. There's no negative radius. There is no radius less than 0. So what does it mean? This sphere equation will not. There is no intersection with YZ plane. So that's the conclusion. So you see that in each plane, you have a different scenario with the sphere equation, correct? So when you hit the XY plane, you will see the circle equation. But when I hit the XZ plane, actually we just hit very tiny. They just hit the point. And the last one, they don't even hit the YZ plane. So that's where this sphere equation existed in the air. Does it make sense? So think about it. So I'm trying to show you the characteristics. So by collecting all the characteristics, you will be able to solve this kind of question. Got you? All right, so we're gonna keep developing the idea, by solving and practicing more and more. So let's take a look at the next question. All right, similar question, but in this time, they want you to find out just equation of sphere when the center is 1 to 3. And then they're actually passing through -1 and 1 and -2. So if you imagine the sphere, the center is going to be 1, 2, 3. And then this sphere is hitting -1 and 1, -2. So this is the situation. They're hitting this point, and then it's going to be create a sphere to find out that equation. So we know the sphere equation is going to be x minus x0 square, y minus y0 square, z minus z0 square. And then let's plugging in all the given information, correct? So if I'm plugging in, what are you going to get? We are going to get r square equal to x minus 1 square. We have a y minus 2 square, z minus 3 square. Am I correct? Okay. So we use the center, and then this equation is passing through -1, 1, -2. So if you remember to find out the linear equation, you plugging in this number into x, y, z. So I will do the same thing. X is -1 because they're passing through. This is your input. So we're going to plugging in. Let's see what you're going to get. So r square equal to -1 square, 1 minus 2 square, -2, -3 square. So this is a 4, 1. This is a 25. That is r square. So from this, we can solve for r, which means r is going to be, so let me minimize. So r is going to be, if you put the radical on both of sides, right, you should get 4, 5, 30. So r is going to be radical 30. So we have all the information. This is the center, 1, 2, 3. And then I plugging in the x, y, z, and we found out the r. So therefore, the sphere equation we got, what do you guys think? This one. So I'm going to plugging in everything. X minus 1 square, y minus 2 square, z minus 3 square equal to r square. R square, we know it is a 30, correct? So therefore, 30. This is a sphere equation. Very simple, correct? So you can find out the sphere equation with the given information as well. So check this out. Very similar like how to find out the linear equation. All right, one more example. Let me go down slowly. All right, so we have a little bit of complicated equations. So they believe that this is going to be the sphere. Ooh, this is a so ugly way. We're going to convert it to x minus x0 square, y minus y0 square, z minus 0 square equal to r square. We're going to change it to this complicated one. So step by step work, right? Because they believe that this is the sphere equation, we're going to just edit it. So I'm going to combining all the x family. So you can find out x squared and minus 6x plus y squared plus 8y, and then z squared minus 4z equal to 20. And then we need to change this into the factor form. So do you remember how to find out the factor form? So I'm going to write it x second minus 6x. You're going to adding some number, subtracting the same number. It does not change anything because it's a zero balance. Y squared 8y. You're going to do the same thing with the y. Z squared 4z, do the same thing, plus minus some number. So what does it mean? We need to find out the number that is going to be in each box. So here, this one, negative 6 divided by 2 square. So you have a 9 here. For the second y variable, 8 divided by 2, second, 16. So you have a 16 here. Negative 4 divided by 2 square, that is a 4 and 4. Why? Why am I doing this? Because this 3 term gonna be a binomial factor. This 3 term, this 3 term. So what happened? I'm gonna write in the bottom. So this 3 is going to be, I'm gonna write the pink, x minus 3 to the second, because that's x second minus 6x plus 9. These 3 is x plus 4 second. These 3, when you find out the factor, z minus 2 second. Am I correct? And the rest of thing, minus 9, minus 16, and minus 8 equal to 20. Beautiful. I'm going to move all the constant to the other side. So therefore, x minus second. Oh, actually, my bad. This one should be y variable. And then y plus 4 second, z minus 2 second, and move the other. So plus 9 plus 16 plus 4 plus 20, you will get 49. So what does it mean? This is exactly the sphere equation we got. So you can say this sphere has a center where 3, negative 4, negative positive 2. So that's your center, because 3 minus, that's how you read it. Many people confuse. So equations say all negative. So negative is a default. Negative is a default. So negative, negative 4. So negative 4 is the center. And then 2. And then radius is a 7. So that's your answer for letter A. Okay, so it's nothing is complicated. You could do it. I think the second example B, you can try. This is the same question with the example 5. So there's a center given. They're passing through that point. So you can find out those equation of sphere in a better form. Okay, so I show you, the one of the popular geometric shape that you're going to see in three-dimensional space is a sphere. And then we talk about its equation and how to find out the radius and center as well. Okay, we're going to keep developing this idea. Okay, we're going to play in three-dimensional space. Okay, let's talk about the middle points. Middle points. So if I'm dealing with the sphere, right? So if you have 2 ending points, right? And then if you divide it by 2 of each ending point, that's going to be the center, correct? So in other words, diameter divided by 2 is a radius. right? So if you know the diameter, no matter where you go, this is a diameter, this is diameter, there's infinite number of the diameter, divided by 2 is a radius. The same thing, if you have a two ending points, if you have a two ending points here, or it could be here, doesn't matter where, if you divide it by 2, that is going to be the midpoint. In this case, that's the center point. So midpoint formula is going to be this. If you have 2 points ending, and then you divide it by that summation, then divide it by that, that's going to be your midpoint. In the sphere, the midpoint will be the center. So therefore, in the following question, what do you guys think? We have two ending points, correct? So one is a 2.1, 4, 4, 3, 10. So let's find out the center, midpoint. So midpoint of sphere between two end points indicates that's the center, correct? So therefore, it is going to be 2 plus 4 divided by 2, 1 plus 3 divided by 2, 4 plus 10 divided by 2. I got it, 3,2,7. That's your center. Am I correct? And we can also find out the radius, isn't it? Because they're passing one of those 2 points. So therefore, radius square, we have x minus 3 center, y minus 2 center, z minus 7 center, correct? And then I need to find out the radius. You can plug in one of the x, y, z into here. So if you want, you can plug in 2, 1, 4, or you can plug in 4, 3, 10. So therefore, r square, 2 minus 1, 1 square, and negative 1 square, negative 3 square. So that would be 1 plus 1 plus 9, 11. So r square 11, r is a radical 11. So therefore, your sphere of equation, finally, x minus the center, z minus the 7, and then 11 r squared, that's your sphere equation. Does it make sense to you? So if you have a midpoint on sphere to midpoint, the half of it, it's going to be center. So you can find out equation of sphere as well. Okay, so it's not really complicated. You can definitely handle this type of question because we are giving you more information. Let me go down slowly. Here we go. So in this time, it's not the, we have 2 points as a given, -5, 2, 3, 3, 4, -1. They're past, and suppose this 2 line is a diameter of sphere. So what that means, you can find out the center easily, right? How? The midpoints of P and Q, that's going to be your center. Same question, right? So you can find out the center point, -5 plus 2 divided by 2, 2 plus 4 divided by 2, 3 minus plus -1 divided by 2. So you will find out the center, -1, 3, 1. And then that is going to be, they're looking for the equation of sphere. So r square, x minus -1 second, y minus 3 second, z minus 1 second. So again, r square, x plus 1 second, y minus 3 second, z minus 1 second. Are you going to stop here or not? No, we're going to find out the r. How? You can plugging in. You can plugging in one of the given point because the sphere, they're going to create a sphere. This is going to be sphere, and then the middle point, that's going to be the center. Okay, so my image is not really beautiful, but anyway, they're going to create a sphere so that you find out the just center. You need to find out the radius. So plugging in either whatever you want, plugging in, I will plugging in 3 for -1, and you can find out the radius, isn't it? So I hope this is same question. This is a literally same question, number 7. So if you're plugging in, what are you going to get? 4 square, 1 square, and -2 square, that's r square. So 16 plus 1 plus 4, we have a 21. So what is your equation of the sphere? Which is x plus 1 square, y minus 3 square, z minus 1 square equal to what? Let me minimize it. Equal to 21. That's r square. We got it. That's an equation of sphere. Okay. So I show you how to find out, equation of sphere by using the characteristic of three-dimensional space from x, y, z. So you can do this type of question. Now I'm gonna show you the real concept 1.2. I'm sorry, 2.2. So I'm gonna go down slowly. Here we go. So we are dealing with r to the third. This means three-dimensional space. Let me just ask you, just very basic question. What does it mean x equal to 0 in 1, 2, 3-dimensional space? So I told you at the beginning briefly, in the first dimension, x equal to 0 means a single point. Correct? Right there. This is x equal to 0. In second dimension, two-dimensional space, what does it mean x equal to 0? This is R1. R2 or R1, R2, what does it mean x equal to 0? Means vertical line, y-axis. Am I correct? This is your vertical line, x equal to 0. You have to passing through the x equal to 0. What does it mean? What does it mean? X equal to 0 in three-dimensional space. Anybody? So x equal to 0, we have xy plane, xz plane, we have a yz plane. And what does it mean x equal to 0? It is going to be yz plane, because yz plane, we do not have any variable from the x-axis. X equal to 0 means in three-dimensional space, it means x0 means it is yz plane. That's what they mean in each different dimension. Okay, so therefore, we actually already talked about it. So we are going to focus on three-dimensional space, right? So this idea keep developing. So I'm going to write, this is a very important slide. Okay, so the rule equation of plane parallel to coordinate plane. So we know x0 means that whatever the points on the x-axis is a 0, so it is, this equation defines yz plane, correct? So if you have a yz plane, if you have any number x equal to 0, as you see that x equal to 0 is yz plane. So if you have any number x equal to 2, x equal to 3, whatever number, that number are going to be parallel line to the yz plane. So that's the same observation we just had above. Does it make sense? So x0 describes all points from the x-axis is a 0, so 0, yz. That's yz plane. The plane in space that is a parallel to yz plane, that means x equal to some number, because you have only x equal to some number, which means, it is a parallel line to the yz plane. So think about it. It's not really complicated. So we have, let's say, I'm just trying to draw the image. Let's say I do have, this is, let's say, yz plane. Okay, yz plane. And then when you draw x equal to 1, okay, x equal to 1, this is a parallel line. They're going to be the parallel line. Okay, same thing. If you have a y equal to 0, we have a 0 on the x. That means it is xz plane. So whatever y equal to some number, it is going to be parallel line to xz plane. Last one, z equal to 0. So it's a xy plane. That means whatever is equal to whatever number, it's a parallel line to the xy plane. Okay, so this is a very, 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 very important valid statement. Very important statement. Okay, so think about it. You have some number x equal to whatever number. It could be higher, it could be lower, but that line is always a parallel line to the YZ. Other one is parallel line to XZ, and then parallel line to the Y plane. So that's the observation we have from here. Okay. So think about it. If I have this one, this is X0. What if I have X equal to, let's say 2? So X equal to 2 is passing through this one, right? So this vertical line and this parallel line, what do you guys think? It's a parallel line in three-dimensional space. They have a parallel line. So that's what I'm saying. This statement is valid statement. Okay. So nothing is a really crazy work. We can do this. Let me show you more examples so you can have a better concept. Let's take a look at the example. So write an equation of a plane passing through the point 3, 11,7. That is a parallel line to YZ plane. Oh, what happened? When a plane is parallel to the YZ plane, only Y and Z coordinates are vary. That means X equal to 0. Thus, this one, we have X equal to 3 is parallel with the YZ plane. Does it make sense to you? So in this problem, 3, 11, 7, right? That is the point in the three-dimensional space. So we have 3, 11, 7. And then we have X equal to 3, right? They're going to be parallel to each other. Okay, so that's a definition. You can think about it. It's not really abstract concept. When, okay, my computer is a little bit frozen. Okay, now better. So when plane is parallel to the YZ, that means X equal to 0. So that you need to find out X equal to some number, which is here. This is the parallel line with the YZ. Same thing, number 2. Find the equation that is passing through. So 6, we have 3 points. What is the plane passing through those 3 all the time? So 6, negative 2, 9, and 0, negative 2, 4, 1, negative 3, negative 2, and negative 3. What do you guys think? Negative 2, negative 2, negative 3 everywhere. So what happened? They have, these 3 points have the same Y coordinate. So therefore they're past this line, this plane is going to be parallel to Y equal to negative 2. So this is the equation to describe this information. So think about it. I'm not using any fancy work, just same work from the definition of the three-dimensional space. Okay, so let me show you more examples. So let's see, we can build up the better concept. So here we go. So in 2 dimension, the graph of equation involving X and Y only, but in 3 dimension, we are involving X, Y, Z. So describe the following region in indicated dimension. So Y equal to 2. What does it mean in our 2 and 3 dimension? So in R 2, Y equal to 2 means what? Y equal to 2 means horizontal line is a horizontal line that is passing 0, 2. That's what they mean. But in 3-dimensional space, Y equal to 3, what do you guys think? Okay, this means, oopsie, I'm gonna write it in 3 dimension, a plane parallel to the XZ plane, because that's where Y equal to 0. And then this is going to passing 0, 2, 0, because that's where y equal to 2. So that's what they mean. So in two-dimensional space, it is just horizontal line passing through 0, 2. And three-dimensional space, what does it mean y equal to 2? We are only passing through the y, and the other thing should be, there's no x and z. So the 0, 2, 0, that's the same as y equal to 2, because a plane parallel to the xy plane, that means y equal to 0. Therefore, it's passing through 0, 2, 0, that is y equal to 2. Does it make sense? So think about it, each meaning in two and three-dimensional space. Continue. What does it mean, this equation in 2 and 3 dimension? 2 dimension, we know what happened. This is a circle equation. Okay, x center 0, 0, and radius is 1, and then this is a less than or equal to. They're looking for the inside of the area. That's a two-dimensional space. To describe x second plus y second is a less than or equal to 1. In 3 dimension, what does it mean? It's going to be a cylinder. So it's going to be like a sphere, but it's a cylinder, which means it's going to be a cylinder of a radius is 1, and then centered along z-axis, because there's a no z. So when you draw the image, this is a z, x, y. So this is what the x second plus y second radius is 1. So if you don't have the other variable, that's where you're locating the shape. So this is a z, this is x and y. Okay, so the center is going to be at the z-axis, and the radius is 1. It's going to be the cylinder shape if you describe that equation. Okay, last one, y is equal to 0. That means mathematically either y equal to 0 or z equal to 0, correct? So what does it mean y equal to 0? That is the x z plane, and then z equal to 0 x y plane, right? So in 3 dimension, it means, you know, it means, you know, y z equal to 0 has, you know, both xz and xy planes. Okay, we don't have like other, you know, yz plane. So it has only 2 planes. That's what they mean. So think about the meaning between R2 and R3. Okay, so this is very important concept. I really want to emphasize on. Okay, almost done. So now you build up all the basic concept of 3-dimensional space. Now let's talk about the vector. So we already learned the vector in 2-dimensional space. It's the same thing. Let me go down. So what happened? Vectors in 3-dimensional space. So you have a 3-component, A1 from the x-axis, A2 from the y-axis, A3 from the z-axis. So we call they are components, same thing. And there's also basic, you know, the basis is standard unit vector. So I is going to be 1, 0, 0, J 1, 0, 1, 0, K 0, 0, 1. So you can write down, let's say we have a vector 2, 3, 4. So this is a vector in 3-dimensional space. You can write it 2 times 1, 0, 0 plus 3, 0, 1, 0, 4 times 0, 0, 4. Oh, 0, 0, 1, because they are unit vector. So what happened? If you solve it, right? This is going to be 2, 0, 0 plus 0, 3, 0 plus 0, 0, 4. So if you're adding them, exactly 2, 3, 4. So you can write down the vector, either that form, or you can write it here. Same thing, 2i plus 3j plus 4k, because I, j, k, they are standard unit vector. Okay, so they're, you know, the way of writing the vector in 3-dimensional space. Same thing. Okay, again, we already talked about, you can find out the length you can find out the distance, the AB vector. It's going to be, subtract each difference, and then position vector is a 0, 0, 0. Just remember, this is not equal to magnitude. Many people confuse. So this is just the, AB vector. This is a vector between 2 points. This is a vector between AB. Magnitude is a length. Okay, so this is a vector. This is going to be the length. So I will show you the difference very soon. So let's take a look at the example. One thing here, you see that they are looking for the vector. So we have a P vector, we have a Q vector. They want to, express PQ, both component form and using standard unit vectors. So here, let's find out the PQ vector first. So according to that formula, PQ vector, it's going to be x2 minus x1, y2 minus y1, z2 minus z1. So that would be -4, -3, -3 minus 12, 2 minus 6. Okay, so that would be -7, -15, -4. Okay, so actually I'm going to get rid of the component form first because I don't want to, because we're going to spend a lot of time in different unit. So let's find out only using the standard form. Okay, so that's the same as we know PQ -7i, and then you can rewrite it minus 15j minus 4k, because ijk, that's your unit vector. Am I right? So you can write down either this way or this way. They're same meaning. Okay, let's go the next example. Same thing. I think you could try this one, right? So try, okay, find out the AB vector. Okay, I'm going to talk about the magnitude right now. So this is the same question. So finally, the magnitude is the length of the vector. So if you have a vector, so we have a vector in the three-dimensional space, x, y, z, right? And then let's say the vector here, a1, a2, a3. So we have a one vector. You can find out the length of this. This is same formula, each component square and put the radical, which is a different. The previous question, you have a 2 points, A and B. This is the vector. I want to describe this vector, and then you're going to find out that each point's differences. So this is not really talking of, it looks like a length, but it's not really. The above question, we're looking for the vector between 2 points. Okay, and then you can, you need a 2 points, initial and the terminal points, to find out the vector AB. This is the length. Okay, so you should know the each. Now you're gonna do, if you find out the length, then you're gonna do -7 squared minus 15 squared, -4 squared. That's gonna be your length. This is just vector. You see the difference? So many people confuse. Once you finish here, you think that this is length. No, this is just vector of a PQ. Now I want to find out the magnitude, the length. Then you're gonna square and then summation with the radical. So don't be confused. They are different, right? This is a different. This is a vector. The next one is a magnitude. So this is the magnitude formula. And if you remember in 2.1, we talk about all the characteristics. You can multiply, you can add in, you can subtract. This is a magnitude, and same like a unit vector formula. Okay, so let me take a look at the example quickly. So that's it. We have a 3 times -295 minus 2 times 1, -1 and 0. So -6, 27, 15, and you are adding -2, +2, 0. So -8, 29, 15. That's letter A answer. Okay. What is a B, right? The B, we have a 5. you need to find out the magnitude of W. So this one will be 1 square, negative 1 square, 0 square, which is a radical 2. So you have 5 radical 2. That's the answer, correct? C, 5W magnitude. So you have to multiply 5 with the W first. Then after, you're going to put the magnitude. So this is a 5, negative 5, 0. Then magnitude will be 5 square, negative 5 square, 0 square. You will get radical 50. Okay? So the last one, unit vector. Okay? So the unit vector formula, we know the unit vector is the length is 1 particularly. So we have a vector, unit vector will be, we're going to find out the unit vector of the u. So you have a u vector, the v vector, and I want to find out the u vector that only length is 1. So the v vector divided by v vector's magnitude. So we already know v vector is a given. Negative 2, 9, 5, and then 4, 81, 25. So you should get negative 2, 9, 5. This is 1, 1, 10, 1, 1, 0. So negative 2, radical 1, 0, 9, and 5. So that's a unit vector of V. Okay, so same concept. 2.1 and 2.2, they're very similar. One is a 2-dimension, another one is a 3-dimension. Same concepts are going and going and again. So the next, unit, we're going to talk about more characteristic in 3-dimensional vector. So I have a couple practice with you, but I'm not going to do it here. I want you guys to try this practice. Okay, so you can organize all the characteristic of the vector system in 3-dimensional space. And then these question is going to be pretty understandable. So try this one. So we talked about, I'm going to actually get rid of this one. Just not the component, only the using the standard. So you can do this. So try 1, 2, 3, 4. It's a pretty understandable. If you have any question, post in our discussion board. Okay. And then you can share your work and maybe we can work together. So check it out. So you can finish. This is also textbook. If you go to textbook 2.2, there's a solution. So check it out. Those are practice 2.2. Okay. So that's it pretty much. So in this video, we talk a lot. We talk about the vector in 3-dimensional space, their characteristic, and one of the popular geometric shape in 3-dimensional space is a sphere. And then you can find out the distance. You can also think about x, y, x, z, y, z planes characteristic, and how to write down the 3-vector system by looking at the, the standard basis vector. So that's all about it, 2.2. We're going to continue to talk about vector in 3-dimensional space in the next video more and more. So feel free to email me if you have any questions. So this question is going to be really, really, really engaging. So you can always work together other people, okay? So I will start recording at this moment. I will see you guys in the next video. Thank you, everyone. Bye-bye.